Here I have a problem from Calculus 1 where we're going to calculate work pulling up a rope. So let's look at the problem. So a mountain climber is about to haul up a 50-meter length of hanging rope. How much work will it take if the rope weighs 0.624 newtons per meter? All right. So the first thing we want to do with any problem like this is start with a drawing, because that can always help us. So we're going to start off. Draw this, and then we'll have something extend here a little, like this, and then here's our rope. And I'm not going to draw it as a line, kind of like a rope. There's our rope. And here we have the 50 mark, because that's the top of it. Right? Then, right here, we're going to choose kind of a it's not a specific part, but it's just any part you want, and we're going to mark this Y. Right? So now we know that this part from here is Y, and then this remaining part here must be, well, if this is Y, the remaining part must be 50 minus Y, right? So hopefully you followed at that point. Now, what we're going to do is we're going to set up an integral, okay? So we have our integral, and let's start with setting the limits of integration. So down here we have 0, and up here we have 50. So we're going to go from 0 to 50. Because that's where the rope is, right? Then what we're going to do is we're going to look at what this part is of the rope, right? So, or we're looking at essentially its weight per meter. So then we're going to put that right here, 0.6, that's not 624, all right? So we put the weight per meter inside the integral, or we could factor it out because it is a constant, but for now we're going to keep it inside. Then we're going to multiply it by 50 minus y, right? And we're multiplying it by 50 minus y because if we go up here, some arbitrary y amount, we're still going to have 50 minus whatever the arbitrary y amount we went up was. So that's what we're multiplying it by. The other thing we could actually do, though, to simplify it, is we could get rid of the 50 minus y, and we could change this to just y. And this will actually result in the same answer. And that's because it's from 0 to 50, and it's 50 minus y. And if you calculate those out, you'll see that every single time it'll result in the same answer. So if you do from 0 to 25, and it's 25 minus y, it'll still be the same thing, right? So then we're just going to evaluate the integral here. We can actually, let's start with factoring out 6 to 4. Draw the integral again, 0 to 50 of y. Then we get 0.624, and then we take the integral of y, which is going to be 1 over 2 y squared, then from 0 to 50, right? Now 50, here actually, so we get 0.624 times 50 squared divided by 2. 50 squared, that's 50 times 50, that's 2,500, divided by 2, that's 1,250. So 1,250, right? And then it would be minus 0 from this part because this is 0. So we can leave it like this, and then we multiply this out, and this equals 780. And let's not forget our unit. Our unit is joules for work, and that is our answer. Thank you for watching. Let me know if I said anything wrong, if you have anything additional to add. Have a great day.